Alrighty, medium one today. Hopefully this will be of appropriate challenge. Okay, so set matrix 0. Okay, given an n by n matrix where if you have an element 0 set its entire row and column to 0, you must do this in place so you don't change, you don't create a new matrix. This is number 73, so it's pretty low in terms of when this was created. So it's pretty simple compared to other mediums. Might be, given the difficulty creep, this might be considered easy today. Alright, if the element is 0, set its entire row and columns to zeros. Why would this be difficult at all? Oh, what is... Huh. I mean, M is the matrix length. Oh, the matrix length is between 200 to 200. So I guess to avoid redundancy, you can determine which rows have zeros, which columns have zeros, and only do it once for row 0. Okay, so let's say 0 rows is a list of rows that have zeros. List? Sure. An array? Sure. For every, let's say, rows and columns is going to be matrix length, and length of the first row in the matrix is the number of columns. So 0 rows and 0 calls. So these are going to be row indices for rows or columns that have a 0. So for every I'm trying to think if it's faster to do it in a 2D array or in a for loop that goes through every indice for row and column. And if CC is 0, you add it to the thing, or if you do a shortcut, or you like if you do a short circuit break. I can't think of which one is faster. For every, let's say, row index in the range of rows, and then for every column, I guess it's just simpler to do a full pass. If value at this row and column, matrix at this row and column is equal to 0, then zero rows dot append this row, 0 columns dot append this column. It's a set, so it should actually, no, this should be a set, because you don't want duplicates. I guess this is just a little bad formatting. So it wouldn't be append, it'd be add. And sets don't have duplicates, so if you add a same element, it just is one element of that in the set. And that's fine. And then for every 0 row, say row in the 0-row sets for every column within that row, then the matrix at that row and column is going to be set to 0 at that point. And then similarly for every column in 0 calls, for every row in that column, matrix that one column is equal to 0, and then no return. Alright, things should be pretty, this is a good first pass before maybe non-trivial improvements. Okay, so it could be better. So how to make this better? Make this better. So if you see a 0, you have to do a full pass. Well, maybe you can short circuit this. Like if you see a 0, then stop going down further that row. Yeah, so for every row, every column in that row, if you see an element that's 0, I think you can maybe do a break here and know that you don't need to do that same row anymore, and at which point you do another pass for the columns, because if you short circuit on certain rows, then you don't necessarily go through all the columns. So for every row in that column, but some columns have already been added because of the row detection. So I can say if the column is in the 0 calls set already, then skip over it. But otherwise, if it is a column that we haven't skipped over, if the matrix at this row and column is equal to 0, then 0 calls, add this column, and then break. Just trying to determine if I could skip over the things that certain rows. I don't think you can, or would be another if statement that I'm going to make. Oh my lord, it actually got slower. Good god. Eeks, eeks, eeks. So for every row and range row, every column and range columns, the matrix at this row and column is 0. Add it. So maybe you just can't do this. I guess you do traverse over the same indices. What if you didn't do an if statement? What is the value? A straightforward solution using O and space is probably a bad idea. Why would you need O and M in space? Simple improvement is O of M plus N space, but still not the best solution. Can you divide the constant space solution? Interesting. Constant space solution. I mean, I think currently it is O of m plus n space because the zeros could be the length of zeros, or the length of your rows, and the zero columns is the length of your columns. Can you devise a constant space solution? Interesting. Zero space solution. Well, I mean, if an element is zero, set the entire row and columns to zero. Oh, I guess maybe when they say straightforward solution using O of m times n, maybe you keep track of all the zeros. Like keep track of the locations of every single zero. And so therefore, because all the zeros, the matrix could be like mostly zeros or all zeros, then the space is proportional to the whole area. But yeah, we definitely didn't do that. Although, I mean, obviously, if it had a very small amount of zeros, it's probably fine. Simple improvement m plus n. Constant space. Constant space solution. Guess maybe they're. So it's from 1 to 200. No, that's not really. It's not really the thing that makes it constant space. So like another trick I'm thinking of is like if I actually just multiply everything inside the particular row or column, if the multiplication ends up being 0, the product ends up being 0 as a result of multiplication, then obviously there's a 0 within that array, within that row or column. So therefore you can set the row and column to 0, then you do need to multiply everything. Not sure if that's worth it. Trading off like more multiplications that are constant speed for versus like if statements. Constant if statement checking. Well, if statement for every if statement check for every value within the row versus like a one if statement check at the end of the row, but more multiplications. Wonder how fast that would be actually. So for instance, if I did, it'd be still m times n, but it might be faster. Let's just have a little whirl. So for every row and range rows, for every column and range calls, let's say product is 1. Product times equals the value at that row and column. And you still need 2 passes too. You need 2 method loops. And then after that, if the product is equal to 0, then 0 rows, not add this row. For the column and range calls, for every row and range rows, that product is equal to 1 again. product times equals the matrix of this row column. If the product equals 0, then 0 rows. Add this column. Okay. And then you skip over this stuff and you reset. Probably complaining about indentation again. Yep. Oh, the indentation needs to be at the level of the last indentation. I see. That's why I'm always screwing this up. Oh, interesting. Zero rows misspelled. This should be 0 columns. Okay. Still misspelled. Nice. Progressively slower and slower. Seeing the more and more inefficient algorithms. Okay. Okay. Well, it's worth a shot. Well, worth a look. Okay, so zero space solution, constant space solution. So constant space solution would be like you have a single number that represents all the rows a single number that represents all the rows and all the columns that you're setting to 0. Can you even have that number? Maybe have like a binary number that's 2 to the like if you map each row and column to be like a bit, if you map each row and column to be a bit, then you'd have a 2 to the 200th or a 200-bit value. The 200-bit value is like 200-bit value. Is that any better? You can have a 200-bit string. You can have a 200-bit array. 200-bit string, 200-bit array. It wouldn't fit into a single integer. I don't think it'd be, well, an integer would be like 32 bits, right? Could make a string, a single string that encapsulates that, but then that's equivalent to like, I don't see how that's all that much better than a set. So my original submission had 18 megabytes. If you did constant time or constant space solution, I can't imagine it's actually that much more. That saves that much space, and you'd have to do like an array. Like a string is just basically an array. String is basically a character array versus an integer array or integer set. Constant space solution. Simple improvement uses O plus N plus N. Still not the best solution. Constant space. Make this constant space. Zeros and zeros. Okay. If any cell in the matrix has a 0, we can record its row and column using additional memory. But if you don't want to use extra memory, you can manipulate the array instead, i.e. simulating exactly what this expression says. Oh, so whenever you detect a 0, you actually change the things. Huh. Interesting. So you go from the top left, you go across the array. That seems so very slow. Or seems like you might be going over the same ones multiple times. So if you see a 0 here, you set everything to 0 in that row and column. And but then if you see another 0 within that same row, then you need to eventually set that 0 to be you see a 0 within a row. I mean, adding like, let's say, a list of where the zeros are, that's the same thing as the O of n times n space. You see a 0, set the stuff in that row or column to 0. And then what? And then you, like in theory, if you do like left to right, top to bottom, looking at the elements, it should always be fine to set the stuff in the top and left to zeros because you didn't detect those to be zeros before. But when you see a 0 and you have to change the stuff to the right and to the bottom of it, in theory you haven't seen those elements before. And you would need to, if you were to set it to 0, then you would need to know that if it's already 0, then you need to change the rows and columns of that element. And then how would you keep track of that? Or would you do it immediately? Did it immediately, that implies recursion, but recursion still uses a stack to basically keep track of the locations of where zeros have been. Setting cell values to 0 on the fly while iterating might lead to discrepancies. What if you use some other integer as your marker? There's still a better approach for this problem with O1 space. Yeah, I mean, like you can set, it's kind of weird because you can't really set it to be a negative, but what would you set to be as your marker in that case? But what if you use some other integer value as your marker? I guess you might use float infinity. Some other value as your. I'm honestly not sure what value you'd use. What value would you use? I'm not sure. We could have used two sets correctly. For an O of 1 solution, you can use one of the rows and columns to keep track of. So I already did hint. I already kept track of it using sets. You can use one of the rows and one of the columns to keep track of the situation. Use one of it. Interesting. I see. So they want me to actually use the matrix itself rather than additional space. O1 being like O1 additional space rather than O of n plus n additional space. Oh. Okay. Well, that's definitely opens up a new train of thought. So if you were to do a swap, if you were to just move this, or I guess you don't need to do a swap, just set the first row or first element of the column to be 0. Okay, so no such. So for every row and column, if you see a 0, then the matrix for this row the 0 column value is going to be 0. The matrix for this column, the 0 column value is going to be 0. For this column, 0, 0. And then for every row, actually, for every column in range, for every row in range rows, if the matrix first element of that row, say not equal to 0, then just skip it. Otherwise, go through all the elements of that column or that row, so all the columns of that row, and change them to 0. Okay, this is not gonna quite work because then it might break the information for the first row. Because when you do the second pass for every column whose first element is 0, if the first row was already 0, then it kind of breaks it. Okay, so how would I not break it? So like what I'm trying to say is, let's say this occurs. Let's say there's a 0 like right here. No, let's say there's a 0 right here. So what this thing did was it would set, because there's a 0 here, it's going to change this to be 0 here as an indicator that this row should be set to 0. But then when this row is set to 0, then the indicators for the columns being set to 0 would be incorrect at that point. So it's overwriting it. Okay, so I mean it's non-trivial to fix that, but there has to be a fix. I think the fix is going to be a constant value. If you have, what is the constant value? You would want some way of knowing whether or not a 0 is like a replaced 0 or a non-replaced 0. So I guess it only really screws up on the first row. So if there's something in the 0 spot on the first row. Oh yeah, also the fact that on the first row a 0 in that spot could be ambiguous. The very first 0 could be denoting that that could be a 0 row or 0 column. So I think maybe you just need 2 variables for that. Yeah. So for the first row, it should just be a boolean. And for the first column, it should just be a boolean. And then anything after that could be indicating it. Okay, so for row and range rows, for every column and range columns, do I really want to use an if statement for this? If the row and column is equal to 0, if the row is equal to 0, then 0 first row, it's going to be false here, it's going to be true here. Now this seems bad. I just want special handling of all of the later rows and columns and 2 for loops for the first rows and first columns. Otherwise it seems like there's too many if statements, I think. So not including the first row and first column. Okay, and then for the first row and first column. So for row and range, okay, so for the first row, so column and range calls 0 first row is false, and the 0 first column is also false. Okay, if the column, so if matrix at the first row column is equal to 0, then 0 the first row is equal to true and break. And then for every row in range of rows, if the matrix of the first element that yeah, or the first column, then 0 the first column is going to be true. Break, and then do it for every other row and column spot, then you can use the first element as an indicator. Okay. Then for every row, if the matrix at that row, this first spot is 0, is not equal to 0, then skip it. Set values in that. Okay, yeah. And then for every column in range calls, the matrix at this first spot of this column is not equal to 0, then skip. Otherwise, for every row in that column, matrix of that row and column is equal to 0. And now, if you want to do the 0 first, if you want to do the 0 first row, then for every column in range calls, then matrix of the first row, that column is equal to 0. If the 0, the first column, for every row in range rows, matrix of the that row first column is equal to 0. Wow, that was, oh boy, not even correct. So what is it not doing here? Okay, so let me print out what is the, so before this is where I determine stuff. So 0 first row, 0 first column, and then the matrix at that point. Alright, so the 0 is dab in the middle, so the first row is not going to be zeroed out. First column is not going to be zeroed out. Because this is 0, the matrix, what is going on here? It seems like a lot of zeros, more than I expect. I really expect like this 0 to cause this column to be 0, and this 0 to cause this row to be 0. Every row in range 1 to the number of rows, every column in, yeah, I think that is the thing. Matrix of this row, oh, whoa, I forgot my if statement. If the matrix of this row and column is actually equal to 0, then do this. I think I maybe deleted too much at some point. Okay, so that worked fine. So there's going to be a zeroing of the first row and a zeroing of the first column, because there's like this 0 and also this 0. Okay. Okay, this 0 didn't cause anything. I see. That 0 should technically have... Well, no. What does this thing do? This 0 should have caused that column to become 0. Ooh, it made all my... What? Everything 0. So for every row in the range of rows, the matrix at this row if the first element of the row is not 0, then it's fine onwards, but if it is 0, then it does this setting for every column in that row. Yeah, so now I'm still back to the issue of the order operations. Am I? Oh, I just need to not do the first row using this thing. Let's see. Could I use the first column doing this thing? If I don't screw up the first row, then I can set up the other ones, and then, yeah, I think it's just screwing up on this first pass, yep. Okay. Okay. Changing it here. Do I need to have 0 first row and 0 first column, or can I just worry about zeroing the first row? Yeah, I think maybe it's possible for me to not have worried about zeroing the first column. It's just worrying about zeroing the first row that kind of screws things up. So if I were to take out the code about zeroing the first column, I think that should still work. I guess maybe not. Okay, so 1, 0. So it should have made... What's going on here? It should have been true for zeroing the first row at that point. Yes, no? 0 first row should be true. That's false. For every column in range calls... Oh, I'm reading this wrong. This is not 1 by 2, this is 2 columns, 1 row, 1 row, 2 columns. No, that's what am I doing? 2 rows, 1 column. This is 2 by 1. 2 rows, 1 column. So at that point, the column. Okay. I think maybe that might be an issue of my for loop actually. Every row besides the first row can be done, but you can still do the first column. Yeah, once you get rid of it. Okay. So let's see if that works. I think slightly more precise about what the most minimal thing is. So everything in the range of the first row and onwards. Everything in the range of all the columns. I did do all the columns here, even if I didn't do it here previously. Yeah, okay, that's fine. Okay, and then you'll need the 0 first column variable. Okay, so in summary, basically instead, so key is how to track which columns, which rows or columns to zero out. Okay. Maybe the easiest or kind of simpler method might be to use sets. Since you just since only one kind of copy of each row or column index needs to be tracked, so you don't have duplicates. Sets don't have duplicates. Sets. Now that would only issue is that takes O of m plus n space. Sets are of the size of number of rows and columns. And I think if it wasn't for the fact that this is asking for something faster or smaller than that, then I think that's fine. So alternatively, since matrix can be changed, like this is in place, can use matrix itself as tracker, which is O of 1 space, O of 1 additional space, since matrix space is provided to the method. So with that, then what you would do is so use the first element of each row or column as marker for whether to to zero that row or column. Okay, the marker being like 0. Only issue there. Only issue is possible only issue there is need to resolve timing issue, because if you zero the first row, that might that influences the marker for the columns, and this would apply for anything. So basically, use a separate track for the tracker for the first row, such that it doesn't break the trackers for the column. So I use a separate boolean to see whether I need to zero my first row, and then I don't zero my first row until when I zero out the rows. So for every other row besides the first row, since zeroing out that row doesn't influence the markers, I can do that. And then I zero out the columns, and then finally I go through another pass and zero out the first row from the boolean. Alright, so time complexity, this is going to be O of 1. No additional space is needed. You do have like one constant variable for the boolean, and then space complexity, and then time complexity. This is still going to be O of n times n, since you need to go through every index in matrix to check array value / index to check if there's a 0, and also to do the 0 process.